In this video, I'll talk about a projectile which is thrown from a height. So what we given here, we have a ball here which is sitting onto at some height from the ground, 5 meters, and the ball is thrown horizontally. It has only the horizontal component, and it is thrown at a 50 meters per second from a height of 5 meters. The mass of the ball is given, which is 2 kilograms. Now the question is, how far it will reach to the ground? How long does it take to reach the ground? What are the velocity, x velocity and the y velocity when it hits the ground? At what angle it hits the ground? Okay, so these are the questions we need to answer. And also we need to answer at time equals to 0.5 seconds, what are the position, where is the particle located? It could be anywhere, so we need to find out the exact position at time equals to 0.5 seconds. Let's do it now. Okay, so as a particle is thrown horizontally, its initial velocity along the x-axis is 50 meters per second. That's what it is given. Now along the y-axis, the particle is not moving at all. The initial velocity along the y-axis is 0 meters per second. The second thing we need to understand, the force. Here there is only one force, and the force is due to the gravity. And the gravity at any point is acting only along the y direction. That's the only force, the gravity force. There is no force acting along the x-axis. So if there is no force acting along the x-axis, what does that mean? That means the velocity of the particle or the projectile is constant along the x-axis. The velocity does not change. As the force is acting only along the y direction, only the y component, the velocity of y component will change. Okay, so that's the key part. There is no force acting along the x-axis, so the velocity will remain constant along the x-axis. As the velocity is as the force is acting only along the y-axis, the velocity will change, or it will accelerate only along the y direction. That's the key part. Okay, so let me answer now the first question. Horizontal velocity of the ball when it reaches the ground. Now you already have got the answer. The horizontal velocity of the ball when it reaches the ground is exactly as the initial velocity. And why is that? Because there is no force acting along it. And here, to make life easier, we're ignoring the air resistance. If we take into account, of course there will be change, but we're just ignoring it. The second part we have to find out is the vertical velocity of the ball when it touches the ground. Okay, now let's find it out. Okay, so this part is already done. Now along the y direction. Along the y direction, what is the initial velocity along the y direction? The initial velocity along the y direction is 0. And now we're going to use this formula here. V squared equals to u squared plus 2gh. The u stands for the initial velocity, and the v stands for the final velocity. Okay, the final velocity when it reaches the ground, we're assuming vgy. Vgy is the final velocity, and the g stands for the ground. Okay, and the u is the initial velocity, so I'm just writing in a different notation now. V0y and 2gh. So now we have all the components given. The initial velocity is 0, 2gh, and I'm just keeping as it is. So if we simplify, what we get, the vertical velocity would be a square root of 2gh. We know 2, it is a constant, g value is 9.8, and height is given, which is 5. So the velocity along the y-axis is 9.9 meters per second. So the key to solve this problem is make the problem totally independent, one along the x-axis and one along the y-axis, and just separate into the different direction along x-axis and along y-axis. So here what I did, how did I find out the velocity? I just take all the components along the y direction, initial velocity, height, and solved it. So that means the velocity along the y-axis here is 9.9 meter per second. Now we need to find out the net magnitude, the total magnitude. As the x and y components, the coordinate systems are orthogonal system, so the total velocity can be given by a square root of x squared velocity and y squared velocity. Okay, so you know that. So this is the, let me explain here. So this is the x component vgx, and this is the vgy. So the total velocity, this one would be given by v squared, total would be given by the Pythagoras theorem. Pythagoras theorem, it would be given by vgx squared plus vgy squared. Okay, so we know vgx, the initial velocity, which was thrown at 50 meter per second, and then we calculated vgy, which is 9.9, and then when you solve it, what you get is 59.97 meter per second. This 59.97 meter per second is the speed at which it hits the ground. Okay, that's the speed or the magnitude of the velocity. Now, how do you find out at what angle it hits the ground? In order to find out the angle, let's take a look at this picture one more time. So this is the x component, this is the y component. So if you have already studied the vectors, so this component and this component is exactly the same. So if you look at this triangle, how you can find out the angle? This angle, the tangent theta in this would be vgy or vgx. That's how you find out the tangent. Okay, so the tangent theta is vgy or vgx. Vgy is 9.9 and vgx is 50. And solve it, and the angle you get is 11.2 degree. That means the projectile hits the ground at 11.2 degree. And now let's find out how long does it take to reach the ground. So again, we're just going to because we have the information along the y-axis, we're going to solve, or you're going to use the equation along the y-axis to find the time. So we're going to use this equation. H is the height, u is the initial velocity, time half g t squared. The u is the initial velocity, that's how we write it down, v0y half gt squared. The height is given, which is 5 meter. The initial velocity is 0 and half g value is 9.8, and here I'm calling t as a time, capital T. This time, capital T, stands for the time of flight. That means how long the object remains in the air, or how long does it take to reach to the ground. That's exactly the same thing. And if you solve, now everything is given. 5 is a constant, half 9.8 t squared. If you solve, you get 1.01 second. That's the time it takes to reach to the ground. And how did we solve it? Again, by just using this equation here, only along the vertical direction. Now we have to find out the horizontal distance covered. What does this mean again? Let's go take a look at the picture one more time. So when the particle is coming down, it is not moving in a straight line, it is moving in a parabolic path. Okay? And the horizontal distance it covered is this distance. So how are we going to figure it out? How are we going to calculate this r? So we already have calculated the time it takes for the projectile to reach to the ground. That's the time. That means the time it takes for the ball to reach to the ground. So we know the time and we know now the velocity along the x-axis. So from that one, we should be able to calculate the horizontal distance. Let's do that. Oops. Okay. Okay. So along the horizontal direction, along x-axis, we're using s is the distance, u is the initial velocity, t is the time, half a t squared. A is the acceleration. And here, remember, this is the horizontal motion or the motion along the x-axis. The initial velocity is 50 meters per second because the velocity is not changing along the x-axis. The key part here is acceleration. The acceleration is 0 along x-axis because there is no force acting along it. So now we're simply writing S as an R. R means the horizontal range or the horizontal distance. This component is now 0. Initial velocity is 50. The time it remains in the air is 1.01, or time it takes to reach to the ground is 1.01. So the horizontal distance we calculated is 50.5 meter. That means this distance is 50.5 meter. Okay, now what are we going to calculate? The position of the ball at time equals 2.5 seconds. So we know the time now. How are we going to calculate the position? The x position is given by this equation. It's the same equation as this one because there is no acceleration. So simply it would be velocity times time. That's what it is here. Velocity time time. The velocity is 50 and we are interested in knowing the position at time equals to 0.5. So just plug it, time equals to 0.5. So 25 meter. So what does this mean? This means, so the particle has traveled 25 meter in 0.5 second. So this distance is 25 meter. Now we need to find out what is this distance, the y. Excuse me. So in order to calculate the y position, we're going to exactly use the same formula. Exactly the same formula. The only difference is, in this case, we're given the acceleration, which is 9.8, acceleration due to gravity. But the difference is, in this case, the initial velocity is 0. There's no velocity. So this component is 0 and only this component is surviving, half gt squared. The g value is 9.8 and the time we are interested in is 0.5 square. So we given the y is 1.225. And remember, do not get confused. This y is from this coordinate. This is our origin. This is our coordinate system here. So this is x-axis and this is the y-axis. So we have calculated x and y, which is 25 and 1.225 meter. So what I would like you to do now, just do exactly the same thing, exactly the same process as a part of your assignment, and or if you are interested in doing more, and then do the same, exactly same problem now 10 meter per second and see what's the number you get, and write down your answer in the comment section. Okay, so again, if you have any questions, write to me, and do not forget to subscribe, like and share my channel. Thank you very much.